Hi, geology students. Today we're going to talk about the structure of the atmosphere as we're getting into our weather unit. Now, you guys have learned, throughout your science career about the different realms of nature. Lithosphere you probably haven't heard about too much, but that's talking about the rocky Earth. We deal a lot with that here in geology. Hydrosphere being all the water on Earth, and the biosphere is all the life forms. But in this unit, we're going to focus on the atmosphere. Okay, and the atmosphere is that thin layer of gas that envelops the Earth, and it's where all of the weather and climates occur. Now, the difference between weather and climate is an important distinction. Weather is going to be, a direct observation at a given moment. So you can go outside and say, hey, it's 70 degrees and it's raining. That would be weather. Whereas climate is patterns and trends of a region over longer periods of time. Okay, so there's a difference between those two. So let's look at first the composition of our atmosphere. Now, if you remember back to Unit 1, we talked about the formation of the solar system, and we had that first atmosphere, which was really just came from that solar nebula, so lots of hydrogen and helium. But then that got blasted off of Earth as the sun, shot out its solar wind. And then we had our second atmosphere form on Earth, which was primarily produced by the outgassing of volcanoes, and it was a lot of carbon dioxide. And then our third and final atmosphere, where we currently are, is the one where we had oxygen finally show up. And the oxygen was produced by life forms, okay? And that's where we are now. So here's my question to you. If you guys know, what are the two gases that make up our current atmosphere, and what's their percentage? A lot of people don't know this, or they have some misconceptions. All right, nitrogen and oxygen. Now, a lot of people think oxygen's the number one thing, but in reality, it's nitrogen. Okay, so nitrogen, we've got 78% of our atmosphere is made up of nitrogen, and then the other 21% is oxygen. Okay. Now, that being said, those things are not really involved in weather. So, although our atmosphere is almost entirely nitrogen and oxygen, they play a very small role in weather. The weather makers are carbon dioxide, water vapor, and dust particles. Okay, those three things are the big players when it comes to creating weather. Now, that should make sense, especially the water vapor, right? I mean, clouds, rain, snow, all that stuff's made out of water, so that should make sense. Now, our atmosphere is layered, and the layered, I'm not going to ask you guys to memorize necessarily every single one, but I do want you to understand that we have these layers, and it's separated based on temperature. And there's a lot of different crazy stuff that happens in these different layers of the atmosphere, but they are separated by temperature. The troposphere is where we are, and this is where the weather happens. This is, your day-to-day life. You probably will never leave the troposphere, okay? Because jetliners are flying pretty much at that top layer right there in the troposphere. If you're going to be an astronaut someday, maybe you'll leave, but all the weather, everything's happening down here in the troposphere. Again, now I'm not going to ask you guys to memorize this, but just gives you an idea of what's going on. And this is why it is separated by temperature. So you can see down here at the bottom, here's the troposphere, and you can see as we're increasing in altitude, the temperature is decreasing, so it gets cooler and cooler, and there's Mount Everest right there, right? Now you get up to this level, this is the stratosphere, and that at the stratosphere it actually heats up, okay, and then the mesosphere it cools down, and then the thermosphere it gets hot again. So it kind of goes zigzag back and forth. And again, that's why we separate those layers based on temperature. But really all we're going to be talking about is the troposphere down here where we live, because that's where all of the weather occurs. So for our purposes, as you rise up into the atmosphere, it gets cooler. Okay, that's kind of what we're going to focus on. All right, so then there's your different layers as you go through from top to bottom. All right, now where does the atmosphere end? Well, it doesn't really have a clear ending because it's a gas. It kind of just gets thinner and thinner and thinner and thinner and thinner, lower and lower density as you go up. And then converse is true as you go down. It's going to become more and more dense as you go down into the atmosphere, and that causes pressure, right? We get pressure down at the bottom there because the gravity of the Earth pulls it down, just like this little column is showing here. So that pressure increases as you get closer to the Earth because that gas is compressible. Okay, so gravity pulls it down and it gets more dense near the surface. So the gravity pulls it down, and then most of those molecules are going to be hanging out down by the surface of the Earth, and we experience that as air pressure. Okay, so it gets compressed down towards the Earth, And then there is a decrease in pressure, and it's roughly exponential as you go to the top. And we'll show you a graph here in a second that'll explain that a little bit more. All right, so big ideas with atmospheric trends. Air density decreases with increasing height, okay? Because it's more dense at the surface, it's going to become less and less dense as we go up higher. Now, as a result of that decrease in density, the air pressure decreases with height. And you guys probably have experienced this, either going up in an airplane or maybe to the top of a building where your ears pop, right? And that's because there's less pressure as you go higher and higher. In general, again, we're talking about pretty much the troposphere, temperature decreases with increasing height, okay? And this is a diagram that's going to kind of show that idea, similar to what we saw on the other page. But here's air pressure along the bottom. Okay, let me maybe get my face out of the way here. All right, so there you got air pressure down at the bottom, right? And then this is your altitude as you go higher, and this red line is showing the pressure. So you can see as we're going higher and higher, the pressure, and actually the pressure decreases pretty quickly as you go. So if you had a hot air balloon and we wanted to go up higher, you know, it's the most dense down here at sea level, and 50% of all the volume of air is within that first 3.5 miles. Okay, but you can see that the pressure quickly drops off. So we go from 1,000 all the way down to 600 just in that first little section. Okay, so it goes pretty fast. Okay, so that decreases very rapidly at the lower levels of the atmosphere. Okay, and then as we increase and get higher and higher into the atmosphere, it starts to slowly decrease a little bit more as you get higher and higher into the atmosphere. Okay? All right. And then once you get up real high, there's very few molecules up there. So it is this trend where it rapidly decreases pressure, and then it slowly decreases in pressure as you get higher and higher. And that's just because there's not as many. All right, here's some questions I want you to answer. Question number 1. What are the 2 primary gases that make up our current atmosphere? We just talked about it. Question number 2. Which gas is most responsible for weather? Now think about this one. Most responsible. Question 3. In which layer of the atmosphere do we live? And lastly, how does pressure change as altitude increases? Look at these options. All right, everybody, thanks. So that's your first lecture of the weather unit, talking about the composition and structure of the atmosphere. If you have any questions, please shoot me an email or stop me in class.